Um, Good afternoon, everyone. Welcome you all for the 99X webinar session. And today we'll be doing the optimizing performance in React apps. Let's wait till the rest of the participants join for about 2 minutes. Okay, welcome everyone again. So let's start the webinar session. This webinar session is totally about optimizing performance in React web apps. So there are some contents where it totally related to React, and there are some contents where you can use it in even in other front-end frameworks like Angular, Vue, even in Next.js. So grab the content and use it as you prefer. So let's start the session. So before we dig deep into the topic, let's talk about why this performance optimization is important to your web application. So as you can see, I have listed down few things that why this is important. So basically, it improves your user experience, and because like uh, nowadays users don't like to wait till web apps load, and they tend to use much faster applications. So they are like you basically they are demanding the fastness of the application. So that's why that is the main reason why this optimization is required. And also when it comes to developer side or the company side or the business side, the cost saving matters. So that optimizing apps will only need few resources, but when it comes to other apps which is not optimized, they need a lot of resources when it comes to hosting and all the other things. But mostly for when we talk about this React or whatever the front end framework, we are working with client side applications. So the only what matters is the hosting. Other than the rest of the things goes to the client's machine or the device they are using. And the other thing is that the competitive advantage is that if let's say for an example, if your web application has an alternate app where people can do the same thing in another app, so if it is much faster, people tend to use it rather than using the our application. So let's say for an example, if that app loads in 1 second, and if our app loads, in order to load our app, it take around 10 seconds, people tend to use the other app. So that's why this is much required. And when it comes to SEO, the search engine optimization, even Google ranks faster sites higher. But that's not the main thing. That's why I put it below. But there are some other things that SEOs check. But this is one of the things that they're checking in their policy. So just for your information. Let's move on to the methods. So basically, when it comes to performance optimization in React apps, there are some certain points that we need to think about. Basically, the memoization, then the code splitting, use transition hook, list visualization, and then lazy loading images, throttling, and debouncing events, React fragments. So I've like in the rest of the presentation, I'll be going through each one of these, but only for some of these, I've added code examples just because of the time constraint we have. And when it comes to React fragments, it's not that important, but it's something. So that's why I've added it here. But I'll anyway discuss it later on. So let's move on. Memoization. So basically, what is this memoization? If someone need to do the memoization to your app, there are three key techniques that you have to use. I'll go through each and every point. Basically, what this does is that optimize the functional components by caching the result. That's what it does. Let's go through these key techniques and I'll explain what it does. React.memo, which caches the output of a functional component, and it stops the re-rendering. It prevents the re-rendering from the application when it comes to components. And use memo. We can use this use memo to cache the output of a function or a data set. Let's say if there's a expensive computation that need to happen in a data set, and once you do the computation, it caches the data. So after a few times, if you do the same computation, it doesn't do the if you added the same filter or something, it doesn't do the computation. It just use the cache and show the data, show the output. And when it comes to use callback, it caches the callback functions basically. And when the re-rendering happens, it prevents the recreation of that specific function. That's what it does. I'm actually not going to show you any example of these because of the time constraint, but you can go through these each and every key techniques and use it as you prefer and according to your business requirement. Yeah, so let's move on to the next part. So the next part is code splitting. We used to split the large JS bundle to in order to split the large JS bundle to smaller parts and lazy load them. Let's say for an example, if there's a menu in your web application, let's say there are 3 menu items. But when it comes to if you load when you load your application, if the whole JS chunk get download, in order to initially show the web application, it doesn't need all the JS chunk. So what it requires only whatever the things that's there in the initial load. So whenever user clicks on the next menu item, that's when you need the other chunk. So That's what code splitting does. So you can split and split the JS chunk and use it as you prefer. I'll show you how to do it in the next slide. And in order to identify whether it takes a lot of memory from your browser or your device, you can use, there are third-party libraries, like even in NPM, there's a third-party library called Webpack Bundle Analyzer. You can use it, and this is basically, most of the times, this is useful if there's an issue in your application when it initially renders it. If there's a slowness in initial rendering, then you can use this code splitting. I'll show you how to do it. So basically, React itself, they are supporting this code splitting. So this is how you need to do this. This suspense is we are getting from React itself, and basically we are lazy loading whatever the component in that route. It can be a route, it can be a component, doesn't matter. We are basically lazy loading the JS chunk. That's what this does. So as you can see, I have used this suspense component. I have wrapped this dynamic component from this suspense, and if there's a fallback, like if there's some time which need to download the JS chunk, it will, until then you can show another component. But basically what this does is lazy load whatever the component. So in here, for the example, I have used this in a single file, but as you can see, I have imported this dynamic component, but it should go to a different file, or you can use it obviously in the same file as well. But for this example, I just copied and pasted the component here in order to show it. Yeah, so that's pretty much about the code splitting part. And we can move on to the use transition hook. So when it comes to use transition hook, it's a React hook. Like it's a by default React hook. Like there are quite a lot of hooks that people are not aware of, even though that's there. People, like, they don't tend to use them because there are they have like the most popular hooks was use state and use effect. They can obviously do the same thing using that, but you have to do you have to add significant amount of code lines in order to cover it. But using this, it will be much easier. You can reduce number of code lines in your code and do the same thing. And the other benefit of using this use transition hook is that it's a low priority uh, like low priority update. So when it comes to use transition, React itself is treated as a low priority, and transition can only be interrupted by a high priority update, whether it can be updated by a parent level. So that's what this use transition hook. I'll show you an example. So as you can see in here, there's a button, and on the button click event, I have used this start transition. So start transition is we are getting from this use transition hook, and what it does is that it just update the this state. So but in order to let's say, for an example, if you have an API call to make, and you have just used the another use state value, like let's say a Boolean value, whether it is pending or not. You have to add the set pending to true and set penned into false, but you don't need to write all that codes. You can simply use this start transition, and whenever the execution finish, it will automatically going to change its state. And until then, it will until you can show the it's whether it is a loading or not. Okay, so that's about the use transition hook. I'll move to the list visualization. So what is this list visualization? So this is for rendering, basically this is for rendering multiple subcomponents or list item in your application. Like if you, let's say for an example, you have 1,000 records to show in your front-end application, and you need to show it like you have to render all the thousand components in your application. But what this does is that this is only rendering whatever the components that are in the viewport. So basically what according to the device, it can be changed obviously, but let's say for an example in your laptop, it takes some significant amount of viewport. So it will show only whatever the content that is visible in your display. So that's what this does. And whenever user scrolls down, or when your user scrolls down, it will load the rest of the components, and it then only it will add to add the elements to the DOM. So that's why it will increase your performance, because otherwise the React app has to wait until all the components load. But using the visualization, it's not like that. Like the perfect example would be the Facebook feed. Like when you scroll it down, it's time to time you can see it's loading and it's updating the feed. So that's what they are doing. Actually, there are multiple phased methods of doing list visualization, like infinite scroll. Even pagination is one of the visualization method. And yeah, so basically how list visualization works is that it replaces the rendered items with new ones as the user scrolls down. So that's what this does. And only the visible portion of the screen will be updated. So it will help you to your responsiveness to update the content. So in the like like when you are using the if you are not using the list visualization, what will happen is that React app will try to load thousands of components in a single page, and it will lag. So you user have to wait till all the components load, and there will be a lag between the user and the application. Yeah, that's pretty much about the list visualization as well. So I'll move on to the next slide. So lazy loading images. Lazy loading is somewhat similar to list visualization again, and assets, basically images, we are calling it as assets. So assets take significant amount of memory in your machine. Or a client application or a web app, basically the web application. But in order to load it in the client side, you have it will automatically get downloaded when you go to a whatever the client application. So that's how it happens. So what are doing here is that you can use lazy loading methods. There are quite a few lazy loading methods you can use. There are multiple third-party libraries, and even in the HTML image tag, it has this loading attribute where you can put as lazy. So then the image will load as a lazy loaded image. But And there are another services as well, like third-party services where you can get this image, like image optimize images, like image kit. I don't know whether you guys have heard, but it's a third-party service where you can upload images and get thumbnails, and then it will automatically identify the device and send you the optimized image for that specific device. Because if you're using a 4K display, and you need to show the full resolution image, but if you're using a mobile device, you don't need to download that full resolution image. So it can be optimized and show it accordingly. So those services are out there, and even there are multiple npm packages you can use. Just try it out. Yeah, so actually that's basically about the lazy loading. And let's move on. Okay, throttling and debouncing events. So basically, throttling is to limit functional execution, and it makes sure that at least it runs once after a specific period of time. And we can set a time interval for a function to execute. That's what this throttling does. I'll give you an example. I have the code even here. So in, like, let's say you have to write you have to do something whenever you user resize the browser. So in those cases, as you can see, I have added this event listener for the resize event, and I've used this throttled handle resize. So what it does is that after this specific amount of time, basically 200 milliseconds, it will call this function and do whatever the thing. So this is the handle. Oh, sorry. Handle resize event. Handle resize function is another function that you need to do. Basically, what this does is that whatever the basically this what this throttle function does is that it check whether whether the handle resize function is already running and whether it took 200 milliseconds. And if it is already running, it doesn't run the function again. If not, it will run. So that's what this throttling means. Then let's move on to the debounce part. Debounce part, I don't have a example code for you, but I'll tell you what are the use cases for this. So basically, the difference between this throttling and debounce is that this debounce is wait specific amount of time after the last event happened. So if the last event finish, and then we can define a time period which we have to wait until the next event start. So that's the difference. And the use cases for this debouncing is for like input validations, search bar queries, because so I'll tell you an example again. So search bar queries, let's say. If there's a search bar, and whenever user types, you have to do a backend API call, basically a REST API call, and get whatever the content to front end whenever user types it. But if you don't use these debouncers, what will happen is that, so obviously you are using the on change event, and whenever user types a letter or a number, it will trigger the on change event, and each time it will there will be a API call to your backend. So in that case, what will happen is it will stress your backend, and like almost all the time, all these API calls are unnecessary, because when you don't need to send API calls whenever user types, because there will be a typing lag even for every user unless it's a bot. So you can use like 300 milliseconds or 600 milliseconds in order to do the next search API call. So that's what this does. So you can use these debouncing methods to cater those kind of requirements, even input validations, those things. Okay. So the next thing is that React fragments. React fragment is actually introduced in React 16.2, and what it does basically is that wraps multiple elements without adding unnecessary DOM elements to your DOM. So you already know React works on a virtual DOM. If there's and it always compares with the real DOM and do the changes accordingly. But if there's an unnecessary element in the React DOM, it's a hassle for the React app. So what this does is that it can wrap. This is the icon that we used for fragmentation, but basically what it does, it just wrapping these things. Sorry. Yeah, it just wrapping these things and making one segment. So that's what it does. So the only thing is that when it comes to React fragment, it does not give you a huge performance increase for your React application. It does give you somewhat of increase, but it's not that beneficial. That's why I put it in the latter part of this presentation. Yeah, that's actually pretty much it about the React performance optimization methods. So the next part, how to do the profiling and monitoring these things, will be done by Peshala, my colleague. So I'll give the mic to him.
Hello, everyone. Okay, thank you, Yashira, and Facial here. Okay, let's move into the next part, profiling and monitoring. So you guys know about how to improve the performance now. So let's talk about profiling and monitoring. So why this is important? So Yashida talk about the ways to optimize your application. So to optimize and the application and to identify the uh, components and places where the optimization should be happen, we should have an approach to identify these uh, things, right? These performance bottlenecks. So this is the place where we need profiling and monitoring. So for that, we have a couple of several tools to profile and monitor these applications. So one is React Profiler API and React Profiler, which comes from the React DevTools, Chrome DevTools, User Timing API, Sentry, Neuralink. Okay, so let's talk about these in separately. So Profiler API. Actually, this comes with the React core library. So it's provide us a component, and we need to wrap the specific part of components that we need to measure the performance uh, by this component, profiler component. So in this component, it has a callback function. It triggers with the on render event, and this callback function has several parameters like mentioning here. For example, it has ID. This ID is basically a string that is used to identify the specific component that we are monitoring the performance. So, and phase. It's about which phase this event is about, which is mount or its update, likewise. And actual duration. It's about the actual duration that it took to render, that component took to commit the changes to the actual DOM. I hope you know about what is committing. Commit is basically, React has a virtual DOM, and commit is applying the changes rendered to the virtual DOM to the actual DOM. So that is committing. So actual duration means the time it taking to apply these changes from the virtual DOM to the real DOM. So that's we are monitoring actual duration, and we have the base duration. It's basically estimated time to uh, apply the changes of the whole subtree, basically the whole components hierarchy in these main component. And the start time when the React begins rendering, and commit time when the React started this commit, and the interactions. Okay. And why we need this profiler API? So assume that we need to do some logging to analyze this performance. Sometimes there can be use cases where we need to log these performance matrices, and if we need to call a backend API to do more analysis about these performances, so in that case we need this performance API, because we can handle these things in programmatically. But this is not recommended to implement this thing in the production environments, because this profiler component also can use some uh, resources actually. So in that case, it's not recommended. But uh, if we need to analyze these performance matrices in the production environment, we can do that, but it is not recommended. So we can use conditional rendering um, to render these profiler component. In that case, basically we can check about the environment of our application, and we can uh, enable this profiler based on the environment. And this is a screenshot about the log, about one log that done by this profiler. So you can see it has this actual duration, base duration, commit time, this time calculated in the milliseconds. So this is the example of a log that done by this profiler. And the user timing API. So this is provided by the modern browsers. So basically what it does is, if we need to monitor the performance of a function, we can use this API. It has, for example, in this code part, you can see it has a start time and end time. So in between those two lines, we can write our logic, and finally we can monitor the time it took to perform this logical part. Likewise, we can use this user timing API to monitor the time that it took to do some logical operations. And profiler, I mentioned about this earlier. So this is this comes from the React Dev Tools. React Dev Tools is an extension. You can integrate add this extension to your Chrome or Firefox browsers. And I think other browsers also has support these React Dev Tools. I'm not sure. You can check that. So this is screenshot I took from the Chrome browser. So after adding these React Dev Tools to your browser, you can see these tab. It's about profiler tab. In here, what you can do is you can load your page, React page, and you can start profiling. You can see this blue button here. After clicking that, you can do the interactions with your web page. Basically, you can add, type anything, or you can do anything you want to monitor. And after stop that record, it will show these kind of tabs. For example, in this rank tab, you can see the components listed here. And also you can see something like this bars. Actually, this bars shows uh, the meaning of this bars is this shows the commits that happened when you interact with this application. Commit is one rendering happened in this with your application when you are interacting. So in one commit, there can be a couple of several components that re-rendered within one commit. So in here, you can see these components has been re-rendered in this interaction, and it mentioned the time which took to commit these changes. So analyzing these time ranges, you can identify the components that are taking too much time. And in this example, actually, it doesn't use too much time. So this is a normal use case. But if this assume that this to-do list is using 2 milliseconds or 5 milliseconds compared to other components, that means it has some abnormal behavior. So we need to look into the code base and identify whether there is some issue in there. So if there's an issue, we can do the optimization like Yashvida mentioned. Okay, and there's another thing, the flame graph. Yeah, this is the flame graph. Actually, it shows the hierarchy of the components that have been rendered in the specific commit. So these green colored ones are the components that actually has re-rendered. They actually has done some change to the DOM. The other ones hasn't done any change in this specific commit. The green ones have done some change to the DOM. And by analyzing these graphs, you can identify the components that taking too much time and the components that rendered unnecessarily. So if these if you see any uh, unexpected component is rendered here, you can uh, you can think, yeah, this should not be come in this commit. I need to uh, do something here, and as Yashvida mentioned previously, you can use that memorization. Likewise, those approaches you can use to stop these unnecessary reloads, re-renders. Yeah, that's about profiler. And there are another third-party tools that we can use as well. One is Sentry and one is New Relic. I mentioned about only these two, but there are many. You can search and know about those things. So what we can do using these third-party tools. So I have mentioned several matrices there. One is page load time, render time, throughput. Actually, throughput is the number of transactions per minute. That means number of page loads, so number of components that has been reloads. Likewise, the number of transactions basically, and route change duration, browser interactions, and the if there are any JavaScript errors, you can see those errors in the Sentry and New Relic. And Web Vitals. Web Vitals is, it has several things. I mentioned only two things: LCP, largest content full paint. It's about the time takes for the uh, large content element to load. Basically, if it's a image or video, that's its largest component. So the time take to load that largest component is LCP, and the FID is first input delay. It measures the time from user start the first interaction in a web page. Likewise, there are many uh, matrices there. So you can try out those things. You can create account in Sentry and New Relic, and you can. It's a simple thing. You can integrate those tools to your front-end applications, and you can monitor those things in real time. Yeah, that's about these tools. Okay, now we move to the Q&A session. So if you have any question, you can ask from me or Yashvita. Yeah, over to you. If you have any questions, you can ask now. Okay, so if there are no questions, we can wrap up this session. And if you have questions, you can reach to us through LinkedIn. Yeah, you can reach to us through LinkedIn. And yeah, thanks for joining, guys. Hope a great day.